What is angular signals? For example, a phone has a price and a quantity. The total is calculated by multiplying the price by the quantity. We also have two methods. The plus method for increasing the quantity by 1. And the minus method for decreasing the quantity by 1. The total value is not recalculated when the quantity value is changed. Signals will allow you to automatically change the total value. Don't worry, Signals will take care of updating the values. The signal delivers a new value. How to create a simple signal? We need to add the signal function call to the initial value. A signal is a wrapper for any value. Signals can wrap values of any type. How to change the value? Signals don't support the standard way of changing values. Operators are not working. The special setter method can change the value. How to get the value? Signals don't support the standard way. The special getter method gets the value. Let's rewrite the code. We get a value from the signal, add 1 to it, and assign the new value to the signal. Let's add signal usage to the class code. We need to import the signal function into the component. First, call the signal function with an initial value for creating the new signal. Now, the quantity is a signal. Let's fix getting a value from a signal. Let's fix updating a value. Now, only the quantity is a signal, but not the total. this is a writable signal. In this case, we cannot use a writable signal for the total. Why? Because the total value depends on the quantity value. In other words, the total signal depends on the quantity signal. Angular has two types of signals, writable and computed. Writable signals don't depend on other signals. Computed signals depends on other signals, writable, computed, or both. Writable signal requires a value. This is an expression with signals. Computed signal requires an expression with signals. This expression is calculated to get a value. How it works? When the quantity is changed, the expression is automatically re-executed, getting a new value for the total signal. In the computed signal, we can set an expression, not a value. We set an expression and the value gets automatically. When the quantity is changed, the total is automatically recalculated. How to create a computed signal? An expression must be inside a function. As a result, the function must return a new value for the computed signal. The computed function is a special function used to create a computed signal. Look how to use writable and computed signals together. Don't forget to import the computed function into the component. Computed signal is always readable only. We can get a value, but cannot set a new value. Don't forget to update the component template. Writable signals support an additional method for changing the value. The value is a current value. The pass function computes a new value from a current value. The function gets a current value as a parameter and can use it in the body. The function must return the new value of a signal. Let's update the minus method. Angular signals support an additional feature called effects. Let me explain what it is. First, we need to import the effect function into the component from the core. The effect function can be called in the components constructor. The effect function call requires passing another function, which contains one or more signals. The passed function will be executed automatically every time the signal value changes. The function has been executed 3 times. The passed function is an effect. Any effect is executed at least once. The first execution identifies the signals in the effect whose values are gotten from a getter. Angular tracks changes in identified signals. In this example, only one signal is tracked. Every time the signal value is changed, the effect will be executed. We can use 2 or more signals in an effect, but we need to do it correctly. In this case, we need to understand one rule. Let's add 2 signals to the effect and see how it works. First, let's add the already existing total signal. When the quantity signal is changed, the total signal is recalculated automatically. Second, let's create an additional signal for this example. When we click on the plus button, the value of the new signal is changed. The new value is a random number. The effect gets the values of multiple signals. In other words, multiple signal getters are called inside the effect. How many times has the effect been executed? 3, not 9. Why? When a signal is changed, the effect is not executed immediately. Angular executes all effects only after changes in signals are completed. All signals are changed after clicking the button. The effect is executed only once, after multiple signals is changed. The effect is executed if one or more signals have been changed. The effect is executed at least once. The first execution identifies the signals in the effect whose values are gotten from a getter. We can create multiple effects. Let's see how. we have created two effects inside the constructor. Any signal can be used in multiple effects. Two effects and two executions. By default, we cannot change the signal inside the effect. This is the recommended practice. This practice will help you avoid some mistakes and problems. If you need to change the signals inside the effect, you'll need to use this option. Signals being changed in an effect without careful consideration can result in loops and other problems. Effects can be created not only within a constructor. We can use a class field to create an effect. In this case, the effect has the name. Angular only tracks signals whose values are gotten by calling a getter. In other words, Angular only tracks signals being read. This rule applies to computed signals and effects. A signal getter call must not only exist, but actually be called. We have created the variable and added the condition to it. In this example, the total signal is 0. The quantity signal getter has not been called. In other words, the signal has not been read. For this reason, Angular will not track the quantity signal inside the total signal. Let's see how it works in practice. The computed signal has been executed. The total is 0. The quantity line has not been executed. Let's click the plus button twice. The quantity signal has been updated twice, but the total signal has not been recalculated. In this case, the quantity is not tracked within the total. Every computed signal has its own list of tracked signals. If at least one tracked signal is changed, the computed signal is recalculated. After the first execution, the computed signal had been recalculated twice. The quantity signal is tracked now. This rule applies to effects too.